All right. So our objective, and please, I see people turning in their warm-ups with no objective. That second column, you got to write that blue sentence every day. Don't forget, okay? So we're going to identify and apply properties of inverse functions after this warm-up on composite functions. So let's talk about this. How to do these was on the notes on Thursday. You had 4 steps, okay? I'm going to follow those 4 steps, but I might combine some steps to make it a little bit more easier, maybe. If less steps is confusing, then just follow the 4 steps, okay? But first step, when we have a composite function, first of all, I have 2 functions to begin with, and I know it's a composite because I see that little O in the middle. F-O-G means F of G, okay? And then backwards, G of F is number 2. All that means is F of G of X for number 1, and then G of F of X for number 2, which is all a fancy way of saying you put one function into another function. So number 1, our first step is we write the outside function. You tell me, which one is the outside function, F or G? F, the beginning one is the outside function. So everybody, let's go ahead and write F of X, if you haven't already, which I hope you already did, but either way, here we go. So F of X is, okay, so F of X equals 3x minus 10. Do y'all remember what step 2 is? Remove the x. Now, if you have a pencil, you could erase it and not have to rewrite it. But I like to rewrite it and make sure I got extra space, okay? Because you're going to replace x with some stuff. So I'm going to rewrite this function, but I'm going to kind of space it out a little more, give myself room. So this is what I mean. F, parentheses, big old space, okay? Equals 3, and instead of x, I'm going to put parentheses with a big old space. And minus 10. Oh my gosh. Try that again. Okay, so do you see how x is removed? This other x is removed. Now I have a space that I can insert the other function, which is what? G of x, okay? So, what goes here? G of x, and then what goes here is what G of x equals, which is 2x minus 1, okay? So again, these 2 blanks, G of x and then 2x minus 1. Put them in those blanks. Now you can rewrite it as another step, or I can just like write it in those blanks, which is what I'm going to do, okay? So again, in that blank, I'm going to put G of x, and in the other blank, I'm going to put what it equals, which is 2x minus 1. This is stuff you would have done on the assignment on Friday, right? What? Did you do it? Yeah. Okay. Yeah, if you did it. Now, that's step 1, 2, and 3 are kind of stuck together. And then step 4 is just to simplify this. Now, can you simplify this, the right side of the equation using PEMDAS? PEMDAS. P stands for what? Parentheses. Now, inside the parentheses, I can't do anything. But outside, what do I call it when I take this outside number and put it in on the inside like this? We do multiply. It's called distribution. Whoop. Now, let's distribute that 3. I like to show it with little arcs. 3 times 2x, and then 3 times negative 1. What's 3 times 2x? 6x. And then 3 times negative 1? Negative 3. So put a minus 3 and bring down minus 10 next to it. Okay, so we've distributed what? Okay. Easy or what? Oh, all right. Now, last step. I want to combine like terms. I have 1x, so I'm going to bring down that 6x. Now, those 2 constants, negative 3 minus 10, what's negative 3 minus 10? Oh, wait. If you multiply them, they turn positive. What? negative 13, okay? Negative 3 minus 10 is negative 13. Just a reminder, two negatives make a positive only when you multiply or divide. But when you're adding or subtracting, they stay negative, okay? So 6x minus 13, and in front of it I can put fog. F composition G. So f of G is 6x minus 13. We did it! How did we do it? We wrote down the first function, we erased the x, we plugged in g of x, we simplified. We did all that on the notes Thursday, we did it just now, and if we can do f of g, we can do g of f. Very similarly. Now, I'm going to do number 2. When I do number 2, I'm going to kind of skip that first step. I don't need to write the whole function. I'm going to just skip to where I leave it blank. Okay? So what's my outside function on number 2? G. So I'm going to write this g of x function, but everywhere I see x, I'm going to leave a space. Okay? So I'm kind of jumping, I'm skipping to the step where I leave a space open. Okay? All right, check it out. G of x. Here we go. G, and instead of x, I'm putting a blank space. Holy moly. Okay. Okay. Equals 2x. So instead of x, I'm going to put a blank space in parentheses, and then minus 1. I write the g function with a space instead of x. What goes into those spaces? The other function, g of f, f is going to go into that g function. So let's go ahead and put in that first blank, f of x, and into that second blank, what is f of x equal to? F of x. 3x minus 10. You might have to write small. Sorry, it looks like I'm writing in the Stone Age. It's all boxy. All right. And once again, does it make sense? What? Are you getting this down? Okay. So next step, we simplify, we distribute, all that stuff. Okay. Just like last time. So the 2 in front of the parentheses is going to multiply, distribute. What's 2 times 3x? 6x. Okay. And then 2 times negative 10. Negative 20. And then bring down that minus 1. And then once again, combine like terms. The 6x is by itself because it's the only x. But what is negative 20 minus 1? Negative 21, so I'm going to put minus 21. And that's g of f of x. Okay. Okay, we had notes on Thursday like that. You had the assignment on Friday. Make sure you turn in that assignment if you've done the front side. Front side only is fine, okay? But we're going to do these notes. So today we're moving on to inverses. And then tomorrow you'll have an assignment and you can finish up Friday's assignment if you need to. Okay? All right, here we go. Not that one. Not that one. That one. Okay. Everybody, you've got the today's notes, 1.5 notes for inverse functions. These are our objectives. You don't have to write these down because you're going to be writing down stuff on the next page. Here we go. So inverse function, how do I get rid of this? I don't need you. Go away. Okay. Well, anyways. All right. Inverse function undoes another function. Okay. It's an undoing. So like to undo a staple, you do a staple remover. Can you think of something that undoes another something? So what undoes a pencil but an eraser? What's the opposite of up? Down. Okay. What's the opposite of writing with pen? Whiting it out. Okay. Writing and whiting. Okay. So can you think of anything else that undoes something? All right. Me either. No kidding. But you get the idea. Inverses are opposites. They undo something. So the same thing goes for math operations. What is the inverse of adding? The opposite is subtracting. I almost said adding again. Okay, so add and subtract. Those are inverses. What's the inverse of multiplying? Dividing. Those are opposites. They undo each other, so to speak. And then what about the inverse of squaring a number? Y'all know what the opposite of squaring a number? Square root. Okay? Square and square root are literally opposites. One is a number times itself. The other one is a number divided by itself. Kind of. All right? The inverse of a square is a square root. Same thing can be said for, you don't have to write any of this down yet, but PEMDAS is how you solve or simplify going forward. If you were going to unsimplify something, it would be SAD MEP. Okay, the inverse of PEMDAS is SAD MEP, which would be add, subtract first, then multiply, divide, then exponents, then parentheses. Okay, so you can backwards unsolve or unsimplify an expression that way. Now here's what you're going to write. Everybody, go ahead and write this down under the first rectangle. Okay, so at the very top, you're writing this down in that box. That first line, we already said, inverse function undoes another function. But I want y'all to notice the notation. Okay, right here. That little -1 is what means inverse. Okay, anytime you see that little -1 up top, an inverse function, the graph passes the horizontal line test. Sorry, a function has an inverse if the original function has passes the horizontal line test. I'm sorry. A function's graph and its inverse are reflections across the line y equals x. Now, I'll draw that for y'all real quick. Whoa. Don't do that. Oh my gosh. Can I click? So y equals x, if you have a function, a coordinate graph, y equals x is this diagonal line through the origin. Y equals x. So when you have a graph and it's inverse, if they reflect across that diagonal line, then it's an inverse function, okay? Does everyone have these four down? Going once, going twice? I'm going to the next slide. All right, so here's a little video on how to find inverse functions. Okay, so anyways, where were we? Okay, everybody, we're going to fill out these steps for finding an inverse. Y'all with me on this table? Step 1, 2, 3, 4. This is going to be very similar to stuff we learned, some of y'all, in algebraic reasoning with your amazing algebraic reasoning teacher. All right. Step 1, write f of x as a y. Okay, so you replace f of x with the letter y. What? Really? All right, step 2, switch x and y. That's the big deal. Whenever we're talking about inverses, we're basically switching x and y. Whether it's an equation, whether it's a table, whether it's a graph, the coordinates of a graph. Okay? Then you have to solve for y. That's the big part where people get stuck. And then your last step is to turn that y back into function notation. But remember, when we have an inverse, we show it with the little -1 right here. Okay? F inverse x. Okay, so for graphically, go ahead and write on the right-hand side, you identify the coordinate points. Once again, switch x and y, and then you plot those new points. The graph will reflect across the diagonal line, y equals x. It's a diagonal line. Okay, these are our steps to find an inverse. Y'all ready to do an example at the bottom? Oh, yes, after the example. All right, so here's our example at the bottom. You already have it on your sheet, right? So step 1 that you wrote down, what do I do first? What do I turn f of x into? Y. So go ahead and write that right below it, okay? Turn it into a y equals 1/3 x plus 2. Everyone understand step 1? F of x is now a y. Cool. Step 2. What do I do with x and y? You switch them. I just wrote that down on step 2, right? So where I saw y, I'm going to write an x instead. Where I see x, I'm going to write a y instead. It's going to look like this. This is the major step where you switch x and y. You're just replacing x with y, replacing y with x. Okay. Then this next part can be challenging. Depends on what you get, but you need to solve for y. Now, do y'all know how to solve for y in a two-variable equation? Because you can't just end solve this, okay? End solve works when you have one variable, but since we have x and y, we have to show each step. So if I'm solving for y, what do I need to get rid of first on this side? The 1/3 of the 2. The 2, right? The 2 is the loner. How do I get rid of a plus 2? The inverse is -2. So underneath it, -2 on both sides, and we can Fruit Ninja slash out those 2's. They're gone. They're opposite. On the left-hand side, now, those of you who I taught before, I know you know this. Better know. What is x minus 2? Oh, I'm dying. Oh. Oh, no. Oh, oh. Oh, I'm having a heart attack. X minus 2. When did you say that? Oh. Hey, so x minus 2 is x minus 2. Now, it's not really a trick question, but when you get here, you're probably going to think, well, what do I put here? Now, if it's a letter, a variable, and a number, a constant, okay, they don't combine. They're not like terms. So if they're not like terms, they go next to each other. So x minus 2 is x minus 2. So that's what we're going to write. Okay, so please don't get tricked by that. Don't put 2x or negative 2x or 2 minus x or some weird stuff. Okay, so there you go. X minus 2 equals 1/3 y. Okay, here's another tricky trick. How do I get rid of the 1/3? What are you listening to? There you go. All right. How do I get rid of 1/3 y in front of y? What do you think? What's the opposite of 1/3 in front of y? Not minus. Divide by what? Okay, well, I don't know. So technically you could divide by 1/3, that's just a weird thing because it's already divided. So what you do is you multiply by its flip. Do you remember the name of the flipping a fraction? What's that called? There's a fancier word. Starts with an R. Reciprocal. Have y'all heard that word before? Reciprocal? Yeah. Okay. Good. So reciprocal is when you flip a fraction. So here's the deal. I want to get rid of 1/3. I'm going to multiply by what? What? No, this is a third. I'm not talking. What's the reciprocal flipped version of 1/3? 3/1, which is the same thing as just 3. Okay. So check it out. To get rid of that 1/3, I multiply by the flip, 3/1, on both sides. Now, over on this side, you got to do that thing we've been doing where you distribute 3 times x, 3 times -2. 3 times x is 3x. 3 times -2 is -6. Sorry about that green. It's kind of hard to see. But now y is by itself. Cool. Now my last step is instead of writing y equals, I have to use f inverse x. It's going to look just like this. F with a little -1, that's your inverse sign. F inverse x equals that. F of x turned into y, switch x and y, solve for y, write it as an inverse, okay? Okay. Now, if you take this function and put it in your calculator, like if you graphed it and you hit Control T and you get a table, you would get these 3 points. We'll go over how to do that later, but trust me, these 3 points are on that table. Go and write these 3 points down, 0, 2, 3, 3, 6, 4. Now, let's see if y'all remember, because I think we did this last year in algebraic reasoning. What do I do to that table to get the inverse? Flip. switch x and y. That's all you got to do. Remember, inverses is just a bunch of switching x and y. So instead of 0, 2, I'm going to have 2, 0. 3, 3 switched around is still 3, 3. And then 6, 4 switched around is 4, 6. Do you see how to get an inverse table? It's probably the easiest thing you can do. Just flip the order. Flip, flip, flip. And could you graph these inverses? So if you graph those first 3 points, you'll get that line. Go ahead and try it. I know you don't have a ruler, so just do your best straightish line. And then if you graph the inverses, you get these 3 points. And then you got to say, is that symmetrical across the diagonal line y equals x? Yes, it is. Make sure you have that written down. Time is shorter than I thought it was, so you're going to use that on the assignment tomorrow, which is over this type of stuff, okay? And then you want to make sure you finish the assignment from Friday as well, okay? All right.